Algebra 2, we're back. We're doing some more about your complex numbers, okay? So we have our complex numbers a plus bi. We should say that, if it's a complex number, it fits into that form, a plus bi. We want to make sure that we have it do that, okay? So what we're first going to talk about today is complex conjugates. And to do that, let's talk about what happens when we take x minus 3 times x plus 3. When we do that, we get the x times x, that's the x squared. We get the plus the 3x. We get the minus the 3x, and then 3 times negative 3 is negative 9. Notice that those middle terms cancel out, and I'm left with x squared minus 9. Now, that has an application for complex numbers. Because here I have two parts, negative 2 plus 3i, so if I take that negative 2 plus 3i, shall we say, and I multiply it by the negative 2, notice that for here, we had the first part was the same, x and x, and the second part was only different because one was positive, one was negative. So I'll keep the first part as negative 2, and then I'll go minus 3i, and I ask you, what happens when I multiply that? Well, the negative 2 times the negative 2 is positive 4. That gives me positive 6i. This gives me a negative 6i, and this gives me a negative, 3 times 3 is 9, and I squared. Well, again, those middle terms, the i's are gone, and I'm left with 4 minus 9i squared. But the great thing is that I squared, remember, is negative 1. So this is 4 minus a negative 9, or 4 plus 9, which is 13. And poof! What do we have? We have two complex numbers that, when multiplied, are just a real number. Now that's complex, 13 plus 0i, kid you not, right? 13 plus 0i, but it only looks real, like the old days. Which it leads to a whole other thing where in math we have this thing called closure. If I have a number plus a number, and they're both real numbers, do I get another real number? If I have an integer plus an integer, do I get another integer? And it turns out, for many things, addition is closed. Multiplication is closed for many things as well. A real number times a real number is a real number. But here's a case where a complex number times a complex number gives me a real number, and you're wondering, is it closed? Well, it is by the definition that this is 13 plus 0i. But it's interesting that it's not the same. I mean, it doesn't look the same. It makes the imaginary part be hidden, okay? So like it's not there. Well, that's what a complex conjugate is, okay? So the complex conjugate, we already saw that, of negative 2 plus 3i is negative 2 minus 3i. The complex conjugate of 4 minus 5i is 4 plus 5i. What's the complex conjugate of negative 3 plus 2, oh, excuse me, I don't want to do that. I'm not really thinking here. 2, that's what I wanted. 5i minus 2. What's the complex conjugate of 5i minus 2? Drum roll. See who can get it right. You're at it written down. You ready to go? See who got it right. How many said that was negative 2 minus 5i? Okay, so remember, this is not in standard form. So first I went and I said, self. What is this in standard form? It's negative 2 plus 5i. There's my standard form. Now I can get its complex conjugate, negative 2 minus 5i. And when I multiply, it'll just look real. The imaginary part will be hidden. Okay? So make sure that you put it back in standard form first before you flip the sign. All right. Now we're going to use that trick, or that complex conjugate, and what happens with it, to go ahead and divide these two numbers. Remember that subtraction is just adding an opposite. We're adding like terms. And division should be multiplying by a reciprocal, but if I multiply the reciprocal of that, I still get the same thing, and I'm kind of stuck. So in the case of division of complex numbers, we're not really going to divide. Well, we are, but we're not. We're going to multiply by 4 plus 5i over 4 plus 5i. Now, complex numbers, you would think that if it's this complex number and it's that complex number, it's the same one, I'm just multiplying by the number 1. So we are. We're not changing it, but what we're going to do, though, because I picked the complex conjugate of the denominator to multiply by, what's that going to do to the denominator? It's going to make it look real. That's great, because then we can put it into the complex form. Because right now we can't put it in complex form. So let's see what we get in the numerator. We get negative 8 Negative 2 times that is negative 10i's. 3i times that is positive 12i's. 3 times 5 is plus 15i squared. All right, let's see what we get in the denominator. 4 times 4 is 16, plus 20i, minus 20i, minus 25i squared. Hey, oh, remember, that should cancel. Let's do some cleaning. Negative 8 minus 15. Remember, I squared is negative 1, right? So that's negative 15. That's going to be negative 23. Negative 10i plus 12i is plus 2i. Let's do some cleaning in the denominator. Hey, those are gone. That's plus 25, right? Because this is negative 1. So 16 plus 25 is 41. And the answer is this division can now be written as a complex number. But we have to write it in complex form of a plus bi. So right now that's not looking like it's complex form, so I have to divide both of them by the 41 to get this to be negative 23 over 41 plus 2 over 41 times I. Notice how I took the second part, 2 over 41, and I wrote it as a fraction that's vertical, it's stacked, and then I multiplied it by the I. Okay, so it looks, hey, what's my real part? Negative 23 41st. What's my imaginary part? 2 41st. Okay, and then there can be no question about that. All right, so that's all we have for day 16, so we should have some other review. Good luck on kind of pulling that all together on the stuff that we did for complex conjugates and division, and there's addition, subtraction, complex numbers, not so complex, I hope. Okay.